Hey everybody, it's Tech Teach again. In our last lesson we were looking at Ohm's Law, kind of reviewing what Ohm's Law is all about, and we looked at the pyramid for Ohm's Law. And we could configure a formula out of this pyramid by covering up any one of the three things. If we cover up V, we know we got IR. If we cover up I, we got V divided by R. If we cover up R, we got V divided by I. So if you know two of the three components, you can figure out using this pyramid how to make the formula work for you and determine different values. So in the next lesson, we're looking at series circuit. A series circuit is some type of conductor, probably a wire that goes around in a loop, and it originates from a power source. This series of slashes here is the symbol for a battery. So this would be DC electricity that we're using, and the longer lead of the battery would be the cathode, and it would go around, and the electricity would flow around the wire in a circle and come back up into the negative part of the battery, the anode. And in this case we've got a voltage of 9 volts on a battery, so we got a 9-volt battery again. You come around the circuit and you see this arrow looking thing. This is a symbol for a switch, and right now the switch is in the open position, which means the switch is turned off, so there's no electricity flowing. You keep coming around and this is the symbol for a resistor. A resistor is a type of material that slows down or impedes the flow of electricity, because you don't want to have too much electricity coming through depending on what size light bulb or load you're doing. You want to be able to control it, so we use resistors to slow down the electricity so that we don't get too much current or voltage in our circuit. And this is a symbol, this circle here with this little W in it is my symbol for a light bulb. So it's just your old standard incandescent little light bulb that you would use. And this light bulb has a resistance value of about 50 ohms. So we're just making up numbers here and throwing things in here so that you can understand. Well, what's the goal here? The goal is to figure out how much current is flowing in this circuit. So we know we have a voltage, we know we have resistance, and we don't know the current. So the first thing you need to look at is the three values. What is it we're looking for? The first thing that we're looking for is voltage. Well, we have one voltage source. So we have a battery that's worth 9 volts. So we replace the question mark here with 9 volts. The second thing we're looking for that we know or can figure out is the resistance. What is the resistance of the circuit? Well, a switch doesn't usually have any resistance in it, unless it's like a dimmer switch or something. Then it's a resistor that acts like a switch. So in this case, our switch is not going to have any resistance value. But the first resistor will have a value of 200 ohms. And the second thing that will resist in this circuit is the light bulb, and it will have a resistance value of 50 ohms. So sometimes you'll have items that are not resistors that provide resistance. Sometimes the wire resists. Okay, so here's a formula. In a series circuit, you simply add up the resistances. The total resistance, R of T, is equal to whatever the first resistor is, the value of the first resistor, plus the value of the second resistor. So in this case, R of 1 is 200 ohms, and R of 2 is 50 ohms. And it doesn't matter which one you put, R of 1 or R of 2. I put them this way because the electricity or the current flow is going this way. So the current will go through this one first and through that one second. So we need to figure out how many ohms we have. We have 200 plus 50, or 250 ohms of resistance. Now we can go back to our Ohm's law triangle, and we can calculate how much electricity is flowing in our circuit by simply using the triangle, covering up the amperage, and we can say that we have 250 ohms of resistance, and we have 9 volts of current. 9 divided by 250 is 0.036 amps. So you can do that